Okay, so my second video is to work out the solution to this second order differential equation, and we want to find the solution to the second derivative of x equal to 3 sine 2x minus cos squared x, given that when x is equal to pi on 2, the first derivative is equal to 1. And when x is equal to 0, then the function's equal to 3. So essentially we're going to anti-differentiate and then use these two conditions to find my constants of integration. So let's have a look at this integral. My first problem that I face with this integral is that I can find the antiderivative of 3 sine 2x quite easily. I can go straight to the formula sheet and go from the formula sheet to work that out. But my integral of the cos squared x, I don't have a shortcut version for doing this. The trick for integrating cos squared x is to use the double angle formula. And the double angle formula that I'm going to use is, I know that cos 2x is equal to, I've got to remember what it is, 2 cos squared x. That's a terrible x. Let's try that again. 2 cos squared x minus 1. So then I can have 1 plus cos 2x equals 2 cos squared x. And then a half plus a half cos 2x equals cos squared x. So I can substitute that into my integral up the top here and integrate that instead. Okay, so now I've got my two parts. I can find the integral of the first part. Now the antiderivative of sine 2x is negative 3 on 2 cos 2x. The antiderivative of sine is negative cos, and you've got to divide by whatever the value is in front of x. Okay, so that's the first part. If I anti-differentiate negative a half, I get negative a half x. And if I anti-differentiate negative a half cos 2x, that would be equal to negative a quarter sine 2x. And I need my constant of integration plus c. So now that I've integrated, I have f of x. All right, now I'm going to use this first condition up here and substitute that in to find out what c is before I go any further. Because if I can avoid having multiple constants represented as letters, I'll do that. Now I'll just work in a separate colour so I don't mix it up with my formulas over here. All right, so when I substitute in pi on 2, I end up with an answer of 1. So I'm going to have 1 is going to be equal to negative 3 on 2 cos of 2 times pi on 2 minus a half times pi on 2 minus a quarter times, quarter times sine of 2 times pi on 2 plus c. Then I end up with this part in the middle here. So that's just cos of pi. Cos of pi is equal to negative 1. So negative 1 times 3 on 2, negative 3 on 2 is positive 3 on 2. And then I'm going to have minus pi on 4. And then sine of pi equals 0. So that whole part equals 0. And then I've got a plus c and a 1. So C will be equal to 1 plus pi on 4 minus 3 on 2, which is pi on 4 minus a half. All right, so I've got my C value. So it's fair to say that f dash of x is equal to negative 3 on 2 cos 2x minus a half x minus a quarter sine 2x plus pi on 4 minus 1/2. And now I've got to start the process all over again and integrate both sides. Now I've already done the conversion with the double angle formula, so this is a little bit easier. The antiderivative of negative cos 2x is negative sign, and I've got to divide by whatever's in front of x. So this is going to become positive 3 on 4 sine 2x. The antiderivative of negative a half x is negative a quarter x squared. The antiderivative of sine 2x or negative sine 2x is cos 2x, and I've got to divide by whatever's in front of x, so it becomes 1/8 cos 2x, and then plus pi on 4x minus a half x. That's a lot of function, and the last thing I've got to add to there is the constant of integration. Now I won't call it C because I used C already. I'm going to call it D this time. Okay, so one very long expression. Now we need to substitute in my next condition, which is when x is 0, the whole thing's equal to 3. So this whole expression is going to be equal to 3 when x is 0. So that looks like this, and it's going to be nice because most things are going to cancel out. Okay, so sine of 0 is 0, so that cancels out. 0 squared is 0, that part cancels out. Cos of 0 is equal to 1, so I'm going to have a value here. This one cancels out, and this one cancels out as well. So most things disappeared, and I'm ended up with 3 equals negative 1/8 plus d. So then d equals 3 plus an eighth, which is 25 on 8. All right, so now I've got my value for d. I can finally say that the function f of x is equal to 3 on 4 sine 2x minus a quarter x squared minus an eighth cos 2x plus pi on 4x minus a half x, and then finally plus 25 on 8. And there's my final expression.